This is a screencast for powers of products and quotients using integer exponents. The objectives for this screencast are that after watching, you should be able to simplify expressions using integer exponents. To have a good understanding of this lesson, you need to be very confident and comfortable in using the rules of exponents in general with our natural or counting numbers. In this lesson, we will learn about using the rules of exponents with integers, and then, in a future lesson, you might want to use these examples to expand into using rational exponents. So, as we review some of our rules, for instance, the power rule, when we're raising a base to a power raised to another power, you end up multiplying those powers. The power rule can also be expanded using a quotient or a product. And we also review that any number to the 0 power is 1, as long as that base is not 0. And remembering when we are working with negative exponents, one way to rewrite a number to a negative exponent is using the reciprocal 1 over that base to the positive power. So let's take a look at two examples. Let's take a look at two shortcuts. Recognizing that we do have a negative exponent and a quotient, what we can do is kind of combine these into one step and say the negative exponent is going to give us the reciprocal, so we would put the b over a. But since we're using the power rule, they each would get the power of n. So this is one way to simplify. Another shortcut is to recognize that even if you have two different bases with two different powers, if both of those powers are negative, you are finding the reciprocal of each. Now again, these are two shortcuts not required to memorize as the other rules of exponents, but keeping them in mind can make your work go a little bit faster. So now let's take a look at two examples. We have 2 to the 6th times e to the negative 4th, and we're raising that quantity to the negative 5th power. What I'm going to do first is take a look inside the parentheses and see, is that pretty much simplified? And for all intensive purposes, it is. What I'm going to do next is then apply my product of powers rule and raise each factor to the negative 5th power. Now, using the power to a power rule, we would get 2 to the negative 30th times e to the positive 20th. At this point, we need to keep in mind that most mathematicians will not keep a negative exponent in their final answer. So what we would do just to this 2 to the negative 30th is find the reciprocal, or make that 1 over 2 to the 30th. And when we simplify, our final answer would be z to the 20th over 2 to the 30th. And by the way, you are not expected to simplify 2 to the 30th. Leaving your answers 2 to the 30th is fine for a problem like this. Taking a look at the next example, again, I'm going to look inside the parentheses, and I notice that for the most part, these are both simplified. There's no work I can do inside the parentheses. So I'll apply my power of quotients rule, and that would be x to the positive 28th, because negative 7 times negative 4 is 28. Then, raising 3 to the 6th to the negative 4th power gives us to the negative 24th. Again, we do not typically leave negative exponents as a final answer, so I would simplify by taking that reciprocal of 3 to the negative 24th, moving that up to the numerator, and making that 3 to the 24th positive. So, those were two examples to help illustrate how you can simplify expressions using integer exponents.